you please confirm? My voice is audible, students. Can you please confirm?
Yes, sir.
Yes, sir.
Okay, fine. 1 second. So let me share my screen. I think you can see my screen also, right? Yeah. Students. So I think in previous class, we have stopped our discussion with respect to these copy constructors. Okay. In other words, actually, I finished the discussion of this copy constructor in the previous class, right? We have finished the discussion of this copy constructor in the previous class. Okay. Now, now, when this copy constructor is invoked, students, a copy constructor is invoked when you're trying to copy the contents of, one object to another object. Okay. So when you're trying to copy the contents of one object to another object, in such a case, copy constructor is going to be invoked, right? Now, second, students, laptop. Yeah, fine. Yes, students. So when this copy constructor is going to be invoked, students, please mute your mic. Yeah. So when this copy constructor is going to be invoked, when you're trying to copy the contents of one object to another object, in such a case, the copy constructor is going to be invoked, right? So how a copy constructor looks like? So by default, a copy constructor is going to be look. Okay. So by default, your C++ compiler is going to define a copy constructor of this style. Okay. When a C++ compiler is going to define a copy constructor like this, if your class does not contain a copy constructor. Right now you see that inside the class called A, there is no copy constructor. Since there is no copy constructor, by default, C++ compiler is going to provide this default copy constructor inside the class. Now, when this default copy constructor is going to be invoked, this default copy constructor is going to be invoked when you're trying to copy the contents of one object. When you're trying to copy the contents of one object to another object. All right. Now, there may be a situation where we need to write our own copy constructor. I repeat, there may be a situation where we need to write our own copy constructor. Why we need to write our own copy constructor? Because the default copy constructor may not work. Okay, there may be a situation where your default copy constructor will not work. In such a case, you need to write your own copy constructor. So that's what we are going to see in today's class, right? How to write our own copy constructor, right? So now in this example, you see that what I'm trying to do, I'm trying to copy the contents of A1 to A2. Now what an object A1 contains? What an object A1 contains? The object A1 contains a data member called A, and the value of this data member is 10. Similarly, okay, here what I'm trying to do, I'm trying to copy the contents of A1 to A2. So now there'll be one more object called A2, and inside this object also I'm having a data member called A. I'm having a data member called A. Okay, so I'm trying to copy the contents of one object to another object. What's going to happen? This default copy constructor is going to be invoked. When this default copy constructor is going to be invoked, so what operation it's going to perform? It's going to copy the value of 10, which is present in A1 to A, which is present in A2. Is it right, students? So we are trying to copy the contents of A1 to A2. This default copy constructor is invoked. So what this default copy constructor does is going to copy the value of 10, which is present in A1 to A, which is present in A2. Right? That's what this default copy constructor is going to do. Now, the most important here you need to observe that. So let us assume that after this statement, there's one more statement. After this, so after this statement, there's one more statement. After this statement, let us assume there's one more statement, and this statement is going to modify the value of 10 to 20. Okay, this statement is going to modify the value of 10 to 20. Okay, now what is the value of a? Now the value of a is 20. Okay, now this a is present inside the object called a1. Now if the value of a is modified to 20, whether it gets reflected in a2 also? I need your answer. Need your answer, students. It gets reflected. You're listening? You understood the question, student?
Once again, sir.
Okay, fine. Now, inside object A1, I have a data member called A. So initially, what's the value of this data member? That is 10. That is 10. Okay. But in this step, what I have done, I am trying to copy the contents of A1 to A2. When I'm trying to copy the contents of A1 to A2, what's going to happen? I'm going to copy the value of 10, which is present in object A1 to to the data member called A, which is present in A2. I've copied it successfully. Okay. So once I copied, next what I've done, I've written a statement. Let us assume that I've written a statement and this statement has modified the value of 10 to 20. The statement has modified the value of 10 to 20. So once I'm trying to modify the value of A from 10 to 20, and this 20 will be reflected in this object also. It gets reflected. That's my question. See, for example, let us assume int a equal to 10. Okay, it's quite simple. Let me put like this. Int int b equal to int b equal to a. Next, a equal to 20. Let me try to print cout 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 a, and let me write cout. Yeah. What is the answer for the students? What's the value of a and
20
what's the
and
value?
10, sir.
20
Sorry?
and 10.
A value is
20.
20 and b value is 10. Here,
10.
what's going to happen, students, when you do like this, a memory is allocated for A. A memory is allocated for A. And what's the value of A? That is 10. Okay. When you write B equal to A, for B, a memory is allocated. And what's the value of B? That is 10. Later, what you have done? You have changed the value of A. That is from 10 to 20. You have changed the value of A from 10 to 20. When I change the value of A from 10 to 20, it is reflecting in B? No, it's not reflecting.
No, sir.
Okay. So the same thing I'm telling here also. The same thing I'm telling. Okay. In this statement, the below I've written one statement on blue color. So in this statement, I'm changing the value of A from 10 to 20. If I'm changing the value from 10 to 20, it won't get reflected in A, which is present in A2. Right. The same thing, the same concept. I'm talking with respect to objects. The same concept I'm talking with respect to objects. I hope now you understood. Have you understood this, students? Have you understood? Yes? You understood? No? I don't know. You understood? No?
Yes, sir.
Actually, this is quite simple. Let me clear my drawings. I don't like to write the complete code. It's quite simple. I don't know why. Um, hmm. Okay, fine. Leave it. Fine. I hope you understood this. Right? I don't like to change the code. Okay, fine. So what I mean to say here, I would like to conclude here. See, one more thing also you can think. Let us assume A1. A1 is having a pen. Let us assume A1 is having a pen. A2 also is having a pen. A2 also having pen. Now A1 has changed pen from blue color to red color. A1 has changed pen color from blue to red color. If A1 has changed pen from blue to red color, okay, it means that A2 also changed the color. No, it has not changed the color. A2 is still using the blue color. Who has changed the color? A1 has changed the color, but A2 is still using the blue color. Here also similarly, if the value of A has been changed from 10 to 20, okay, it won't get reflected in A, which is present in A2. And that's what I would like to say. Why? Because I said that each object will have its own copy of data members. Why? Because each object will have its own copy of data members. What it means? A1 is having its own copy of A. A1 is having its own copy of A, and A2 is having its own copy of A. Okay, the A which is present in A1 is different from A which is present in A2. Okay, the same thing here also. The blue color pen which belongs to A1 is different from the blue color pen which belongs to A2. If if A1 is changing the blue color pen to red color, it does not mean that A2 also has changed. Why? Because each person is having their own pen. Here also, each object is having its own copy of data member. Since it is each object is having its own copy of data member, if I'm changing the value in one object, it is not reflecting in other object. I hope you understood this. If you understood this, then only I can discuss copy constructors. Have you understood this, students? Have you understood? Any response from you? Understood?
Yes, sir.
Yeah, okay, fine. Fine. That's good. Okay. Now let me erase all this stuff. Let me put here. Okay. Now let me do it. Let me change my color pen. Yeah, fine. Now let us assume that I'm doing an operation called. 1 second. Let us assume there's an object. Okay. Let us assume there's an object. Okay. Try to understand, students. The name of the object is S1. And let us assume there's one more object, S2. Okay. This S2. The two objects are there. Okay. Now this S1 is having a data member called len. Okay. And it has a pointer variable. It has a pointer variable called CSTR. It has a pointer variable called CSTR. It has a pointer variable called CSTR. And the CSTR pointer variable is pointing to an array. The CSTR, 1 second, it is pointing to an array. 1 second, let me remove this. Let me draw the array first. Let me draw an array. 1, 2, 3. Let us assume the contents of this array is hello. H, E, L, L, O. Okay. As you know that since it is an since this array is an array of characters, the last character will be \0. Okay, the last character will be \0. I think you must know this, right? Let me change the color. The last character will be \0. Why \0? The \0 indicates the end of the string. Okay, the \0 indicates the end of the string. It's nothing but an array of characters, right? Now, CSTR is a pointer variable which is pointing to this array. Okay, CSTR is a pointer variable which is pointing to the array. As you know that, see, so let us assume the starting address of this array is 1000. The starting address of this array is 1000. Okay, when pointer variable is pointing to an array, when a pointer variable is pointing to an array, it always points to the starting address of the array. It's very, very important. When a pointer variable is pointing to an array, it always points to the starting address of an array. So what is the starting address of the array? That is 1000. So therefore, the value of C star will be 1000. Value of C star will be 1000. And for example, I think, let me illustrate this. I have written int, int, int star p, int star p. And let me write int, int a equal to 10, and then I return star p equal to address of a. Okay. So when I write a statement like this, what's going to happen? When I write a statement like this, what's going to happen, students? When I write a statement something like this, it happens like this. Okay. When I write int a equal 10, when I write int a equal 10, for a memory is allocated. Okay. For a memory is allocated, and what is the value of a? That is 10. This statement. Next, what I return? Star p equal to address of a. So as you know that for every memory location, they'll be having some address. So let us assume the address of this memory location is 1000. Next, what I return? Star p equal to address of a. In other words, p is a pointer variable which is pointing to this address. Okay, p is a pointer variable. P is a pointer variable which is pointing to this address location. Why? Because I return star p equal to address of a. In other words, this p contains the address of a. And what's the address of a? It's nothing but it is 1000. Okay. So here also I have done the same thing. So CSTR is a pointer variable which is pointing to this array, Okay. When a pointer variable is pointing to an array, it always points to the starting address of the array. It always points to the starting address of the array. And what is the starting address of the array? That is 1000. So that's why I assign the value of C star to 1000. Okay, that's why I was saying the value of C star to 1000. Okay. Uh, have you understood, students up to now? In case you have any doubts, you can ask me. Okay. Have you understood up to now? Any questions you can ask. Have you understood, students, or any questions? Any response from your end? Have you understood?
Yes, sir.
Only Abhishek is responding. And what about others? Akila, Akshay, Akshita, Amulya, Ankit, Anuswa,
Yes,
Ashwini,
sir.
Ayush Goyal, Bharat, Bhavyashree, Yukta, Chandana, Dania, Darshan G. Naidu, Deepa, Dhanush, Lakshmish, Harini, Arsha D. Why you're
Yes,
not
sir.
responding, students? You should respond, okay? Surjwala, Vamsi, Jayant, Vaishnavi, Anzar Ahmad, Deepti. Understanding what I'm telling?
Yes,
Yes.
sir.
Okay, fine. You should respond.
Yes, sir.
Okay, fine. Good. I think up to now you understood, right? That's very important because if you not understood this, so you don't know what is the use of this copy constructor. In other words, when we should write our own copy constructor. If you understand this, what I'm discussing, then only we'll come to know when we should write our own copy constructor, right? Now let us assume that now I've written a statement something like this. Okay, written S2 equal to S1. Written S2 equal to S1. So now what I'm trying to do, I'm trying to copy the contents of S1. I'm trying to copy the contents of S1 to S2, right? When I write S2 equal to S1. Now what S2 will be having? See, S2 will be having len. And having a len. And not only that, it also has star CSTR. It also having a pointer variable called CSTR. Right, student? Now here what I'm trying to do, students, I'm trying to copy the contents of S1 to S2. When I'm trying to copy the contents of S1 to S2, what's going to happen? I'm trying to copy the value of S1. So what's the value? Sorry. I'm trying to copy the value of len to len, which is present in S2. Now, what is the value of len, which is present in S1? It's nothing but it's the length of the string. And what is the length of the string? 1, 2, 3, 4, 5. So the length of the string in S1 is 5. Since I'm trying to do S2 equal to S1, in other words, I'm trying to copy the contents of S1 to S2. So therefore, the value of 5, which is present in S1, I'm trying to copy to len, which is present in S2. And therefore, the value of len is 5, which is present in S2. And similarly, I'm trying to copy the address, okay, the address of CSTR, which is present in S1 to CSTR, which is present in S2. And what's the value of this? The value of this is 1000. The value of this is 1000. I'm trying to. What is this 1000, students? What is this 1000? This 1000 is nothing but this is an address of the array. Which array? This array. Okay. 1000 is nothing but it is address of this array. In other words, this CSTR is also pointing to the same array. Is it right, students? Okay. In other words, this CSTR is also pointing to the same array. I've understood. The most important observation you have to do here is both CSTR, that is CSTR which is present in S1 and CSTR which is present in S2, both are pointing to the same array. Both are pointing to the same array. Why it is pointing to the same array? Because when I'm trying to copy the contents of S1 to S2, I'm trying to invoke a default copy constructor. What this default copy constructor does, what it does is try to copy the contents of S1 to S2, right? How it's going to copy? So this is going to copy. We call this as member-wise copy. What is a member-wise? S1 is having a member called len. S1 is having a member called CSTR. And what's the value of this? 5. And what's the value of CSTR? It is 1000. So what value it is having? The same value it's going to copy to S2 also. So that's why we call this as a member-wise copy. Okay. The most important observation you have to do is both CSTR is pointing to the same array. Okay, both CSTR is pointing to the same array. Okay, but this is not correct. Okay, both CSTR should not point to the same array. Both CSTR should not point to the same array. Why? Because what's the definition of an object? A definition of an object says that each object must have its own copy of data members. I repeat, what's the definition of an object? Each object must have its own copy of data members. But when you come to here, what's going to happen? You see that this data member, you can think as a data member. This data member is shared among these two CSTR. CSTR which is present in S1 and CSTR which is present in S2. These both CSTR are going to share the same array, which is not correct. Why? Because the definition of an object says that each object must have its own copy of data members. Have you understood this, students? Any questions? You can ask.
Yes, sir.
Have you understood? Have you
Yes, sir.
understood? Okay. Understood, students? Because I need response from your end.
Yes, sir.
Okay, fine. That's good. So now what I should do? I need to remove this pointer. Let me remove all this stuff. Now what I should do? I need to remove this pointer. In other words, I should not make CSTR to point to 1000. No, I should not make CSTR. No, I should not make CSTR to point to this array. So what I should do? What I need to do? I need to make the CSTR to point to a new array. I need to make the CSTR to point to a new array. I need to make the CSTR to point to a new array. And not only that, what I should do, since I'm trying to copy the contents of object S1 to S2, right? Since I'm trying to copy the contents of S1 to S2, and the value of this array also must be hello. The value of array also must be this hello. Okay. This also must be hello. Okay, let us assume the address of this is 2000. Is 2000, and the value of CSTR must be 2000. But this behavior, what I discussed just now, this behavior cannot be achieved. Okay, this behavior cannot be achieved with respect to default copy constructor. Okay, this behavior cannot be achieved with respect to default copy constructor. So in order to achieve this sort of behavior, what we should do, we need to write our own copy constructor. So now let us see how to write our own copy constructor in order to achieve this sort of behavior. Okay. Okay, fine. So now let me write the code. Okay, the code which I'm writing is quite interesting and try to understand. Okay, it's quite simple. There's nothing tough. Okay, you can easily make it out. Okay. It's quite simple. You can try to do it. Fine. You're fine, students. So now step one. Now, so what is S1 is containing? Let me change the color. Yeah, yeah. What is object S1 is containing? S1 is containing two data types, that is len and a pointer variable called CSTR. Okay. So now let me write a class. Let me remove this. Let me write a class called string. Let me write a class called string. And inside this class called string, I have two data members. One is len, int len, and one more is pointer variable. It's an array of characters, right? The CS star is pointing to an array. That is nothing but this array contains characters. So that's why I'm going to take CS star as array of characters. That is a pointer variable. Is a pointer variable. You see that? Uh, you see that CSTR, what is CSTR? CSTR is a pointer variable. CSTR is a pointer variable. Where it's pointing to? It is pointing to array of characters. Since CSTR is pointing to array of characters, I have taken the type as char. Okay. But here you see the students, I have taken the type. Here you see that I have taken the type of pointer as int. Why you have taken the type of pointer as int? Because you see that this pointer p is trying to point to an integer. You see that the pointer p is trying to point to the address of an integer variable. Since this pointer p is trying to point to the address of an integer variable, I have taken here the type as int. But here that is not the case. Here CSTR is trying to point to an array of characters, and that's why the type of CSTR is CSTR is char. Okay, fine. Let me erase this. Yeah, fine. Ignore that. And next inside this, let me write a constructor string, and let me define this constructor. Let me define this constructor string, string, string. Yeah. So inside this constructor, and let me do step by step. Here is this. Uh, fine. String. Okay, fine. Now inside this, okay, I define a constructor. This is a constructor. This is a constructor. Okay, and next inside this, let me create an array. char str equal to created an array. Okay. Now let me pass this array to the constructor. So let me create an object of a class called string. Let me create an object of a class called string, that is s1 equal to, sorry, non s1. Let me pass this string. Okay. So I have created an object called s1. At the time of creating an object called s1, what I'm trying to pass an array. Okay. Now since I'm trying to pass an array inside my class called string, what I should do? I need to find a constructor, okay, which is pointing to this array. Okay. Now can you find? No, I don't have any constructor. So what I should do? Let me have a pointer star. Let me write it here. Star p. Return pointer. Listen very carefully, students. So here what I've done, initially I've created an array. Okay, I've created an array. It is H E L L O. I've created an array. Okay. Now let us assume the starting address of this array is 1000. What I've done, next I have passed this array. I pass this array to here. When I'm passing, what I'm trying to do, I'm trying to pass what I'm trying to do. I'm making this pointer variable p. This pointer variable p is pointing this array. Pointer variable p is pointing to this array. And what's the address of this pointer variable? It will be 1000. Sorry, the value of this pointer variable will be 1000. Okay, so that's what I've done here. Is it right, students? Now, students, the most important thing is, see, what is the name of the array? The name of the array is str. The name of the array is str. As I always says that a pointer variable always points to the address of a memory location. Students, with respect to array, when I write str, okay, this str is nothing but this str always refers to the starting address of an array. This str always refers to the starting address of the array. When I'm trying to pass str is nothing but here I'm passing the starting address of the array. So what is the starting address of the array? That is 1000. So this ptr, that is this pointer p is pointing. This pointer p is pointing to the starting address of this array. I think you must know all these coding concepts. I hope you understood this. Only one thing, students, here what I'm trying to do, I'm trying to pass an array. So when I'm trying to pass an array to this pointer variable, then p is a pointer variable which is going to point to this array. The most important thing you should understand here is when I mention str is nothing but it is the starting address of the array. As you know that a pointer variable always points to the address of a memory location. Since it's a pointer variable, we need to pass the address of your array, that is str. Yeah, I hope you understood this. Yeah, fine. Now this is step 1. Okay, next let us do step 2. So now let us step to step 2. In step 2, what I'm trying to do, okay, let me compute the length. In order to compute the length, I'll be using an inbuilt function called string length. I'll be using an inbuilt function called string length of p. Okay, and the string length of p I'm assigning to variable called len. Okay, now you see that, students. Now what is this len? This len refers to s1. This len refers to s1. Why? Because I'm trying to call this constructor with respect to s1. Okay, and now I'm trying to compute the length of p. What is the length of p? P is pointing to this array. What is the length? 1, 2, 3, 4, 5. So the length will be 5. So that's what I'll get. In object called s1, you see that in object called s1, the length will be 5. The length will be 5. Is it right, students? And that's what I've done here. Okay, let me erase this. Yeah, and next, it's quite important here. Next, what I should do, I'm trying to dynamically create an array. Okay, that is len plus 1, and this I'm pointing to cstr. Now this is quite interesting, right, to understand. Okay, so what is this new? What is this indicates that? Okay, new char means dynamically new. The keyword new says that whenever you see the keyword called new means dynamically I'm going to create an array. Okay, this array is nothing but this array is going to hold characters. That's what it says. This array is going to hold characters. And what's the length of this array? That is length plus 1. And what's the value of length? Just now you have computed 5. Why is this 5 plus 1? As I said that when I'm trying to create any array, the last character will be \0. So that's why this 1 has been included, right? So I'm going to create an array 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I'm going to create an array. So new char is nothing but dynamically I'm going to create an array. So once I create an array dynamically, what I'm trying to do, I'm trying to make this pointer, that is cstr. You see that this entire dynamic array I have assigned to cstr. It means that the cstr is going to point to this dynamic array. The cstr is going to point to this dynamic array, and let us assume the value of this is 1005. Okay, let us assume the value of this is 1005. Let us assume the value of this is 1000. Okay, it's not value, the address. The address of this array is 1000. So therefore, here the value of cstr will be 1000. Okay, now cstr is trying to point to a dynamic array. Okay, now what I should do, students, now the contents of this array, that is hello, the contents of this hello, that is contents of this array, I need to copy to this dynamic array. How I can copy? Let us see now. In order to copy the contents of the array to this dynamic array, what I should do, I'm going to use string copy. I'm going to use an inbuilt function called string copy, and I'll be writing here CSTR comma CSTR comma P. What it means that it says that I'm trying to copy the contents of P to CSTR. It says that I'm trying to copy the contents of P to CSTR. As you see that here, P is pointing to this array. P is a pointer variable which is pointing to this array. And what's the contents of the P? The contents of P is hello. This contents, what I need to do? I need to copy this dynamic array. As you see that CSTR is trying to point to this dynamic array. So now I'll be going to copy the contents. So it will be HELL. As you know that last character is \0. So like that, successfully I have created successfully CSTR is trying to point to an array. Okay, so this is done. So I have done this now. So let me clear all this stuff. So next, what I need to do? Next, I need to copy the contents of str. I need to copy the contents of S1 to S2. Okay. Now, when I'm trying to copy the contents of S1 to S2, by default, it's going to invoke a default copy constructor. So as I discussed, with respect to default copy constructor, this behavior cannot be achieved. So that's what I've discussed right now. So what I should do, inside my class, I need to create a default copy constructor. How to create a default copy constructor? That is string, having string address. Discuss this in the previous class, how to write a default copy. String string address SS. Okay. Now what I need to do, students, here? So what I need to do inside this default copy constructor, I need to copy the contents of S1. I need to copy the contents of S1 to S2, right? I need to copy the contents of S1 to S2. Let me see. I need to copy the contents of S1 to S2. How I can copy? Let us do here. Okay. Now here, len equal to s len equal to ss dot len. See, students, I have discussed in the previous class. When you write S1 equal to S2, I'm sorry. When you write S2 equal to S1, when you write S2 equal to S1, I said that I'm calling default copy constructor. Sorry, I'm trying to call a copy constructor with respect to S2, right? So since I'm trying to call a copy constructor with respect to S2, okay, this len belongs to S2. And as I said that this S1 will be passed as an argument to SS. This S1 will pass as an argument to SS. So this SS is nothing but your S1, right? So this S1 is nothing but is your SS. Okay. How to access the length value which is present here? ss.length. When I write ss.length and the value is nothing but it is 5, and that's what I've done. ss.length is nothing but it is s1.length. Okay, s1.length is quite similar as ss.length. And what's the value of this? That is 5. And this 5, it is nothing but it is 5. And this 5, what I should do? I need to copy this length. So this length refers to S2. So therefore, so the length which belongs to S2, I'm trying to copy a value called 5. Okay. So why this length belongs to S2? Because I said that this copy constructor is invoked with respect to S2. So S2 is my current object. With respect to this current object, I'm trying to invoke this copy constructor. I hope you understood this, right? So let me clear my drawings. This is some of the coding stuff which you need to make it out. That's all. It's quite simple. And next, what I need to do? Next, I need to dynamically create an array. That is dynamically new char. I do. Students, this
Excuse me,
session
sir.
might get terminated. You can use the same link